Today we're going to learn about radicals. So I'm just going to get straight into it. So a radical problem on a test would look something like this. Root 50, and they want you to simplify this. So let me show you how this works. You're looking to find something, you're looking to find a number that is a perfect square. So like something that you can bring out. So let me show you what that means. So for this, it's 25 times 2. And then root 25 is 5 squared. So you can bring it out like this, 5 root 2. You know what, let me rewrite this so it's more clear. You can do this. You can break this out into its own individual, I guess, houses, like square roots, like this. And then now, if you didn't know, root 25 is 5 times root 2. So, in other words, it's just 5 root 2. So yeah, it's pretty simple, but it can get a bit weird. Really, all radical problems in this course, it all boils down to the idea that this this like fundamental, I guess, idea that, oh my gosh, let me write this. If you have two numbers under one house or one square root, you can put them in their own houses. And that's like pretty much every single question. This is all that this entire course is about. Okay, so let me do another example. Okay, so let's do let's do 27. So root 27. You're trying to break 27 up into two numbers, one of them containing a perfect square. So let me show you, like, I guess, the strategy behind it. So you have 1 squared, 2 squared, 3 squared, 4 squared. I'm just going to write a few of them down. 4, 9, 8. Oops, that is not right. 16. These are your perfect squares. Can any of these numbers become, so you know how I'm going to break this into two numbers, A and B. Can I use any of these perfect square values that I have on the right to break 27 down? And the answer is yes. So you can use 9 for this, because 9 times 3 is 27. So replace 27 with 9 times 3. And then now that we have this, we're going to use that kind of fundamental idea thing, that if you have two numbers under the same house, you can break them into their own houses like this. And since 9 is a perfect square, you can put that in a calculator, or if you know how to do it already, it's just 3. Root 9 is 3. And then root 3, you just bring down. So this is kind of like the simplifying part. Another question that they can ask, and that I kind of have a strategy for solving as well, is stuff like this. 9 root 7 minus 3 root 7. And let's say they ask you to simplify and solve. Simplify and solve. So this one is easy. It's just 9 minus 3. It's 6 root 7. And you might be wondering, well, what if you have, like, instead of 7, it's like root 8? well then you can't simplify it. So that's all you can do. Let's do a slightly harder one. So imagine they give something like this, where you have to both add and simplify it as well. So root 3 is already like as simplified as it can be. Root 27 is so big, it's probably like able to become smaller. So let's try it. So what are two numbers that we can break 27 into, and one of them containing a perfect square? We did this earlier, but it's the exact same. So 9 and 3. I will not skip any steps for this. So root 9, so since they're under the same house, we can break them into their own houses, like that. And then root 9, it just becomes 3. So 3 and root 3, like that. So now minus 2 times 3, it's negative 6 root 3. Now, these are all the same, and because they're the same, we can just add them up like this. And then let me show you an example where if they're different. So imagine you had 5 root 2 plus 3 root 7 plus 4 root 2 minus 2 root 7, like this. Some of my students struggle with this as well. So if you have root 2, you can add the ones that have the same square root together. So 9 root 2, because of these two, and the root 7s are the same. So you can add those together. 3 minus 2 is 1 root 7. And then one trick that I do, if my students are still confused about this stuff, is let's replace the ones that have the same number under it with a. So root 2 becomes a, root 7 becomes just a random letter, b. So 5a plus 3b plus 4a minus 2b. And now, hopefully it's more clear, but the ones that have the same letter to it can just add together. 9a, 3b minus 2b just becomes 1b. And now we just transform them back. So a is root 2, b is root 7. And that's just a fun little strategy that I like to use. And I want to do one more example, which is something they could ask is multiplying radicals. So imagine you're given something like this. So I want you to think of it as the same as normal math. So you just expand it like this, right? Expand 2 times root 3 times 4, and then you do the other term. So let's see what that looks like. 2 root 3 times 4. How about we skip no steps at all? 2 root 3 times 4 plus, I'm going to put brackets because it's very confusing to look at like this. 2 root 3 times 5 root 3. Remember, it's the distributive property like this. We're multiplying it out like this. Okay, let's start with this left term. So it's 2 times 4. 8 root 3. Then the next term. 2 times 5 is 10. Root 3 times root 3. What is that? That's why I was saying earlier that this entire like lesson is based on that thing I showed earlier where the two houses break down into their own houses. This is the exact same thing. Two numbers that are multiplied together in their own houses can go under the same house, like this. And that's really just root 9, right? 3 times 3. So we can replace root 3 times root 3 with root 9. And root 9, it's a perfect square. Root 9 is just 3. And then you just keep on simplifying. 10 times 3, 30, until you can't anymore. So yeah, this is radicals. The stuff that they can ask is simplifying stuff, like what we did in the beginning here. Oops, over here, like root 27, root 50, adding them together. And then they can ask multiplying questions as well. But if you're practicing, I'd just do adding and multiplying, because like stuff like here, we have to simplify. So by practicing those two things, you're in turn practicing simplifying itself as well.